task in this pair of problems is to identify what translation occurred as we shifted from f of x to g of x. Effectively, if I know what this graph is going to look like, how do I translate it to look like this graph? Again, it comes down to knowing our rules. For example, I have a plus 1 on the outside. Anything outside of the parentheses of my original, because effectively this is like saying parentheses x squared, and I can see there's my square there. Outside is going to be a vertical change. What you see is what you get when it's a vertical change, so plus 1 means up 1. Now, that minus 2 there, it's inside the parentheses. That's going to indicate some kind of horizontal change, perhaps a translation left or right. If it's inside the parentheses, it's the opposite of what I would expect. Since it's minus, I would normally expect that to be to the left, but again, it's in the parentheses, opposite, sent it off to the right. So, this means I went to the right 2 units. So I would best describe this translation as right 2, up 1. And that would be my entire statement. Up 2 units, up 1 unit, sorry, up 1 unit, right 2. And I'm done. Let's look at another one. This example kicks off with f of x equaling x to the third, and g of x equaling the quantity 2x raised to the third. So what I need to do is look and see what's different between the two functions. I can see that I've included a new multiply by 2 inside the parentheses. Now, anything happening inside the parentheses represents some kind of horizontal shift. So when I look at that 2, since it's inside the parentheses, I know I'm talking some kind of horizontal motion, either a left-right translation or a stretch compress. I've got this 2 here. Now, if I'm pulling it out from the inside, I do the opposite. So we're talking about a factor of a half. 2 over 1 becomes a half. And since that would effectively be a product of half, I'm going to call it a compression. So effectively, g of x looks like f of x, but it has been compressed horizontally by a factor of 1/2. I might also say compressed by a factor of 1/2 horizontally. Now try not to get too into abbreviations this early on. Otherwise you'll lose yourself in your own notation. Remember, whoever's grading your quiz has to have an idea of what it is you're talking about as you work your way down to shorter forms. I just write it all out for the practice for now. What we have in this is we're going to be taking log base 4 of x, and we're going to transform it to match this, and our objective is to identify exactly what happened to it along the way. So let's start working left to right and see how each of these changes the final function. I've got a 2 on the outside. Now, anything outside my original function is going to be a vertical change. So I know that's a vertical shift of some kind. It's being multiplied on. So that means we're going to be stretching this by a factor of 2. Remember, vertical things are what you see is what you get. The horizontal changes are the ones that are the opposite. No change on the x, but I do subtract 1. Now that's inside the parentheses, so that's a horizontal change. And specifically, plus minus means we're going to be translating it. And, as I said, vertical is what you see is what you get. Horizontal is the opposite. So minus 1 is actually going to be to the right 1 unit. Now normally we would expect minus to be left, but again, horizontal is the opposite, so we're going to the right. Last but not least, we got that plus 2 tacked on the end. Now it's on the outside of the original, so that's a vertical change. And it's 2 units plus, so that's going to be 2 units up. Again, the vertical is what you see is what you get. So the net result of all 3 of these changes is that I'm stretching it by 2 units, translating it to the right 1 unit, and then taking the whole thing and translating it up 2 more units. So for example, if I had originally included, say, this point here, it would now move 1 unit this way, and then 2 units up, and there would be my new position, and so forth and so on. And then the whole graph gets stretched by a factor of 2.